Hey, welcome back. This is Jordan Deshawn again here to give you an explanation of Step 2, water supply, where we're trying to answer the question, what water supply system is proposed to meet the needs of the community? So on this tab, we're going to be defining what the pumped safe water supply system characteristics are. Again, as a reminder, on the right side of each tab of the spreadsheet, there's a free space for notes or additional information or even calculations. So you can use this space as you feel need as you go through the design tool for any notes or calculations you want to include for yourself. Here under step 2A, we answer the first question, what water source will be used? And you can select from a drop-down menu from different types of water sources. If none of these are applicable, you can select other. If you have selected other, be sure to give an explanation of what the water source is here in this box. And regardless of which source you choose, you can also use the box to describe important characteristics of the water source, such as concerns in use, ownership, seasonal changes in yield or quality. Speaking of yield, the next section is water source yield. So the first question is, has a yield test been performed? And you can select yes or no. In this case, the engineer has written no, and that draws our attention to this box, which says if the answer is no, explain why a yield test has not been completed and how the maximum yield and dynamic water level were estimated in order to continue with the design. So the design engineer has written maximum yield is estimated based on other water sources in the region, and a yield test will be completed after drilling. So the maximum yield, which was estimated from other water sources, is 120 cubic meters per hour. And then the maximum allowable abstraction is 100%. If that's an unfamiliar term and you need to read more about what that means, you can hover your mouse over that cell. Because it has this red triangle in the right corner, you can hover your mouse to see a definition and a note will appear. So all of that gives us our allowable yield of the water source, which is 120 cubic meters per hour. Step 2B is about water quality, where you can fill in the water quality testing results in this table. The three parameters that are always here, because they're in white here, are turbidity and then bacteria, total and fecal coliform. You can enter the result here for those. And then if you have additional water quality parameters that exceed water emission limits, you can select those from the drop-down list here in the rows that follow, and then enter the results and units here. Well, the units actually appear automatically based on the parameter that you've selected, so that's pretty neat. If you need more information about water quality guidelines that we use, you could click this reference hyperlink that'll take you to the references tab to read more about it. And then in this box, if water quality testing has not been completed, explain why and any assumptions that are being made for the design. And you can also include any parameters that you might not find in the drop-down list here. You could describe those in the box. But here we read that the water quality testing will be completed after drilling and used to confirm the required water treatment equipment. But the anticipated result is that coliforms are expected in the water quality, which influences the next section, step 2C, water treatment. The first question is what kind of pre-treatment is required, and you can select from the drop-down list here. Again, for any of these, if you select other, always be sure to use the box below to give an explanation. Next is what water emission treatment equipment is being used. We have either the erosion chlorinator or the living water treatment system. On previous design tools, the erosion chlorinator was referred to as the potable water chlorinator, or PWC, but now we use the term erosion chlorinator. Then after that, if there's additional other forms of water treatment, you could select those from this drop-down box, this drop-down menu. And then finally, This is your opportunity to be detailed and descriptive of the water treatment system. So describe the process, how water will flow through the system. And in this case, the design engineer has written that water will flow through 2 erosion chlorinators operating in parallel for disinfection. After that is step 2D, about water storage, where we answer the question, how much safe water storage will the project have? Here, the design engineer has written 20 cubic meters. And the general guidance is that between 0.5 and 3 days of water storage, so that's based on the water demand, should be used. And if you need to, you can click on this link to an optional calculator to help you calculate what that value might be. Finally, we get to step 2E, water distribution. And we answer the question, how will the design population access water? We can select again from a drop-down list. And in this case, if you've chosen combination or other, be sure to give a description here. But you can also use this box to give a general description of the water distribution regardless of which method you select. Then we enter the number of access points or locations. In this case, it's 130, which you might remember is the number of households for this community. So it looks like this is a household connection project. And then the number of taps is the same, just 130. There's then this automatic calculation of the number of people per tap. That's not necessarily applicable here since we're doing household connections, but for community tap projects, Water Mission aims for no more than 250 people per tap or faucet. Finally, at the very end, we get a summary of all the key data and outputs from step 2. And that's the end. Next, in step 3, we'll be looking at hydraulic design. So thanks for watching, and as always, please feel free to reach out to a Charleston engineer if you have any questions or need support using this tool.